Let us divide polynomials. When we are going to divide polynomials, it's always safe for us to assume that there is an application of the DLE, or what we known as the Division Law of Exponents. Now, we use the multiplication law of exponents when we talk about the multiplication of polynomials in the previous video. And here, we're also going to entertain ourselves with the application of the division law of exponents, which tells us that if we are going to divide terms or coefficients rather with the same basis, let's say x to the power of 5 divided by x squared, we are going to subtract the exponents. Copy by copying the base and subtract the exponents 5 minus 2, which could actually yield to x cubed. But please be guided that we cannot interchange the exponents here and say 2 minus 5 because subtraction is not commutative. The minuend in the subtrahend should be correct. The minuend is the exponent of the numerator rather, and the uh, subtrahend is the exponent of the denominator. Why I'm talking about this? Because as we go to numbers 1 and 2, we're going to have this one. But wait, number 1 and number 2 are very different when it comes to the solution. Why? Look at the divisors. Please be reminded on what are the divisors. The first term that you will see are called dividends, while the second terms that you will see is actually the divisors. Look at the divisors for number 1 and number 2. In number 1 we have a monomial divisor, and in number 2 we have a binomial divisor. We do have separate processes for the two. When we could use one process rather that could be applied in both, but I am sure that the process I'm going to apply or advise you to use in number 1 is easier to be understood for a monomial divisor, while the separate operation is good for a binomial divisor, which is in a number 2. Let's talk about number 1 first. We have here a multinomial, 3x squared y plus 12xy minus 9x squared y cube, x cubed y squared rather, minus 6xy to the power of 4. And to be divided by a monomial here. To do this, let's just simply try to consider this operation here. If I'm going to, we could actually write this in a form of a rational expression. And what is that rational expression, sir? The rational expression is actually a fractional form of the division process. If we say 5 divided by 2 in our elementary years, we could just simply write it in a form of a fraction, which is 5 over 2. The division symbol became this division bar, while the dividend is on the numerator and the divisor is on the denominator. So we could use the same thing here. Write all terms of the numerator of the dividend rather as your numerator. That would mean 3x squared y plus 12xy. Let me move this a little bit for sorry. All right. And you have here minus 9x cubed y squared and minus 6 y to the power of 4. And you will have here the division bar. And you have here 3xy on the denominator. This is an example of a rational expression. Rational because there are variables that can be found in the denominator. Why are you going to use this process? Because I'm going to let you use the process that is actually the reverse operation of this method. Okay? When we have here 5 halves plus 1 half in our previous grading, we could actually add them up by copying the same denominator since they are similar fractions. We have here 2 and you have here 5 minus 1 on your numerator. Now do not proceed to saying 6 over 2 or 6 half and the 6 halves, then saying 3, because my point is just explaining as to this process. If in a fraction form we could do this form here, we are going to use the reverse operation that out from this expression we could get separate fractions. So 5 plus 1 all over 2 could be rewritten as the sum of 5 halves and 1 half. In applying it in this step here, we could actually use this process. Look at what happened here. The same denominator was shared to all terms and separate them by the operation of plus. Okay, let's just use plus so that we could actually have the same understanding as the previous video in multiplication and probably the next step later on. Let's just use plus again as operator. It will not hurt us anyway. As we remove grouping symbols later on, it's easier for us to remove them. So I'm talking about this one. So the 3x squared y shall have the same denominator, 3xy. Separate by a plus. Next term is 12xy, just like what happened here, wherein 5 plus 1 all over 2 can be rewritten by reverse process, 5 halves plus 1 half, share the same denominator here. And then plus still, don't worry about that. You have here minus 9 x cubed y squared all over 3xy. Some of you might say I could use here minus, sir. Again, don't worry. This is just my advice, simplest form, plus negative 6y to the power of 4 over 3xy. The point for this is that once we have each of the separate terms, instead of looking as a whole, we could apply here independent division processes. And then the division law of exponent is eminent here. 3 divided by 3 is 1. And then when we divide coefficients with the same base, we subtract the exponents. And by means of subtracting, do it properly. X 2 minus 1, as 2 is the exponent of the numerator with variable x, and 1 and for the denominator. For y, you have 1 minus 1. Okay? That's just for the first term. Second term, plus 12 divided by 3 is 4. You have your x 1 minus 1, and then y 1 minus 1. And then plus again. Not worry about the negative because we're going to have parentheses here. Negative 9 divided by 3 is negative 3. And then you have here, sorry, x 3 minus 1, y 2 minus 1. And finally, for the last term, still parenthesis, negative 6 divided by 3 is negative 2. And then you don't have any y in the numerator. That's x rather. You don't have any x in the numerator. So we still have the x on the denominator. It's not paired to anything. And you have your y 4 minus 1. Sir, why is it that y now, using division law, is placed on the numerator? Sir, since it doesn't have any, we have here x in the denominator. Looking at this will become without fractions, without any denominators with variables. So they stand as similar to a whole um, number or integer. It stands as it is. So that's why it looks like this. Okay. And that next step, apply the necessary steps. So one could be without no longer written here. X 2 minus 1 is 1, so it's like that. Y to the power of 0 plus 4 x to the power of 0 y to the power of 0 plus negative 3 x squared y power of 1. Now, let me write 1 here, plus negative 2 y cubed all over x on the denominator. Okay? We are not yet done because we are going to look at these expressions here with zero exponent. Take note that there is a law of zero exponent telling us that a term, a coefficient, or an expression with zero exponent could be written as 1. Take note that the zero exponent is only for y here. It doesn't include x. It has a separate exponent. For the second term, the zero exponents are only for the variables x and y. The 4 is not included since it also has a separate exponent here. So it will look like this. X, we don't need to write 1, times 1, that will actually be times, okay, multiplication, because y to the power of 0 is 1. Here, plus 4 times 1 times 1. And then here plus, or let's try to remove the grouping symbols. Here, it's plus preceded by the plus sign. So if you still have problems with this, you might want to review the previous videos. You have minus 3 x squared y, and here minus 2 y cubed all over x. We still have denominator x for the last term as it has uh, no other variables to be combined here. The final answer here is just by looking at this as 1x or x plus, this is just simply 4 minus 3 x squared y and minus 2 y cubed all over x. Looking at the terms here in this multinomial, we don't have similar terms, so this is our final result. This was made possible by looking at the divisor as a denominator and sharing it on all the terms and applying the correct mathematical operations. This is for number 1. We cannot use this for process in number 2 since it's incorrect for us to say I will divide this sir by x plus 1 as well as this as well as this, and as well as this expression. No, because you cannot further simplify it if you have a binomial expression in the denominator. Take note that if you have an expression just like this, 1 plus 4, you cannot cancel that out. Probably some of you might be thinking about that. Since we don't have here the operation separating the terms in the denominator is not multiplication. And cancellation law, in its longer name, is cancellation law for multiplication. So let's not do that. Before we could proceed to the proper step for number 2, let me move this down to have it separate space. And let me increase the spaces here, the bottom, that we could have more scribbles. The right process to be followed when we are using we're going dealing with the division of polynomials with a binomial divisor is the process of long division. Again, long division. You may also encounter synthetic division, but let us not talk about it yet. Let's talk about the long division because that's the part of our competency. The long division is patterned to your long division process. Let's say 231 is to be divided by 11. This is actually taken from the original given, which is 231 divided by 11. In short, following this number to this form, the divisor, or the dividend rather, is placed inside this bar while the divisor is placed outside. So let's use that here. Let's have this long division and place the dividend 2x cubed minus x squared plus 4x plus 7 inside this grouping symbol. And you will have here x plus 1 for your divisor. Take note that I have placed parentheses for the divisor so that it will be taken as a whole, as one divisor. We don't need it for our elementary procedure since if we talk about 11, it's just really 11. Here we have a variable x, so it should stand as a whole. The processes in long division for this um, given is again anchored to the elementary procedures. Let's look at our example here. 23 for us to divide this, we will start with dividing 23 by 11. In short, we are not dividing the whole yet. even if it's too easy to look at. But I'm talking about if there are other numbers, so on and so forth, then we cannot actually look at the whole, it as a whole. We are going to look at the first possible terms, or digits rather, here, that could be divided by this process here. And that means dividing divided by 11, or how many 11s are there in 23. Your quotient is placed here. The point for this is to anchor that here by dividing the first term, not the whole, not just the two, only the first, by the first term. That's the technique. So the division of the first term to the first term. That's the first process. And when we divide, we can actually use the division bar here as a rational form of expression, because it's easier for us to use the division law of exponents. So to do that, you have 2x cubed divided by x, and get the first quotient by dividing the terms. 2 divided by 1, we have 1 here, is 2, and use the division law of exponents, x cubed minus 1. The first quotient is given to be 2x squared. This is the first quotient. I'm saying first quotient, not just the quotient, since we have involved the first term of the dividend only in this process. We have not touched the rest. Just like here, the first quotient and 2, and we place it here at the top. So similarly, this first quotient will be placed here, which is 2x squared. This is just the first part of the first group of steps. I'm saying group of steps because it is termed as long division, and definitely it will take a longer process. Let's to talk about the next process. Let's talk about here. The next process is actually multiplication. The multiplication of the first quotient to the divisor. And if we are going to multiply it, it's not like 2 times 10 only, or 2 times 1. It's 2 times 11 as a whole. My point for this is when you multiply that, you will get 22 here. To anchor this in our process, we are going to multiply this first quotient to the divisor. And if we say divisor, it should be multiplied to the whole. It would mean both terms. It will follow this process here. We are multiplying the first quotient, 2x squared, to the divisor, x plus 1. So it is taken as a whole. And if we would like to review this process, we are just going to apply the distributive property. And by the way, this is why some of the activities I used before in this course or subject is that I only give one item for long division for the whole of operations on polynomials, since in just one example for long division, just like this, we have divided already. The next step is multiplication, and later on we are also going to touch about the addition and subtraction. See, one example only, the four operations could be included. My point here is in this process, distributive property, you might want to review how to multiply polynomials in separate videos. And you will have 2x squared times x, separate by a plus, and you'll have 2x squared times 1. To continue, you have 2x2 plus 1 plus 2 times this is just 2x squared times itself. The final answer, use the multiplication law of exponents because we are multiplying, add exponents. Earlier, division law, since we are dividing, so subtract exponents earlier. But here, adding exponents, 2 plus 1, you have 3, and you have 2x squared. Please do not add them since they have different literal coefficients. This is the first product when we multiply the first quotient to the divisor. And where do we place this? Look at this example earlier. We place it just directly with the first digits that we used. So here we're going to place the same thing here. So we'll have, let me change the color to another, let's say orange. You'll have here 2x cubed here and plus 2x squared. This is the second step for the long division. The third step is again anchored to the third step of this. In your elementary years, you are then to subtract. And when you subtract 23 minus 22, you will get 1 and place the first difference here. Similarly, we are also going to subtract in this area. Here comes one of the biggest problems in the long division. Please be guided that when you subtract here, you are subtracting a binomial and it should take as and it should be considered as a whole. My point is when we are going to do this, let me subtract. Okay, I will be using green here. Subtraction. We're going to subtract this. You can still see the first two terms of the divisor. You have 2x cubed minus x squared. That's your dividend rather, to be subtracted by the first difference, which is actually 2x cubed plus 2x squared. See the process here. There is a grouping symbol. And remember that if we are going to remove this grouping symbol preceded by a subtraction sign, the signs here will be changed. See this one. You will have here 2x cubed as it is minus x squared as it is. But when you remove this grouping symbol preceded by a subtraction symbol or a minus sign or a negative sign, the positive 2x cubed will become negative 2x cubed. And this plus here will also become minus. This is the result of distributing the sign. Negative times positive, negative, negative times positive, negative. As to why I mentioned earlier, this is one of the biggest problem. When we look at this originally, and if we are not going to consider a grouping symbol here, simply as this, you might be confused that here, this operation is still plus. But look at what happened earlier when we used the grouping symbol. Look at the sign of 2x squared. It became minus 2x squared. This is the more appropriate process. So please do not forget to always put a grouping symbol, especially when you're dealing with subtraction operations. So this is the process now, and simply try to combine 2x squared minus 2x squared is 0. Negative x squared minus 2x squared, two negatives added or you will have added to each other, you will have negative 3x squared. If you have some confusions as to how they are added or subtracted, please try to review the operations on integers and the previous operations. So this is your first difference. And that is what we're going to place here, similar to what we have done with 1 here. We are going to place negative 3x squared. We are not yet done because we do have other terms yet here. Similar to this elementary procedure, whatever is left, whatever digit is left here, you are going to bring it down and you will place it as another digit. So place here the another digit. Let's just start with 4x and do not add 7 plus 7 yet because it will confuse you later on. Because once you brought down this digit, you're going to repeat the same processes. So 11 divided by 11, you start with division, you have the answer of 1. After that, multiplication, 1 times 11, 11. That's your second step. Third, subtraction, and you will have here the result. By the way, I would like also to emphasize this one important thing. I know that some of us, per our understanding during elementary years, are used to doing this, placing x here as a symbol that the result is 0. It was good in our elementary years because x means nothing. But when we reach grade 7, especially in math 7, where variables could mean any other things, just like x could be 1, x could be 2, x could be 1 half, 1 million, square root of 3, 1/3, there are many possible values for x, and thus let us avoid using this. If the result is 0, and definitely write 0. We may be able to look at use it here later. That's why I am emphasizing this. My point for this is, again, once we brought this last digit down, repeat the operations. So once we brought plus 4x, repeat the same operations. And what are those operations? We start with the division of the first term to the first term. Let me write it here. The division, so you have here negative 3x squared to be divided by x. This will result to negative 3x power of 2 minus 1, or simply negative 3x to the power of 1, or simply 3 negative 3x. This is the second quotient. The second quotient here was placed beside the first quotient, and as therefore we're going to place it here. But it would be wrong if I'm going to make it like this. Take note that if you are overusing parentheses, it may automatically mean multiplication. So what should be the correct form? Simply write the result. Negative 3x, it will become minus 3 x. The negative becomes the operation as the reverse operation also of what we have been saying earlier, that the operation could be the sign of the next term. Next is the operation for multiplication. Multiply the second quotient, negative 3x, with the divisor, x plus 1. Use the distributive property and you will get negative 3x times x plus, use plus separator as always, negative 3 times 1. So negative 3 times 1 is negative 3, and you will have x 1 plus 1 squared. By the way, I automatically added the exponents since they have the same base. Plus, here you will have negative 3 still. And removing the grouping symbol, you have negative 3x squared minus 3x as your second product. Place the same term here below this group here. So negative 3x squared minus 3x. Next step, subtract, but please be guided that when you subtract, use a grouping symbol indicating you are subtracting the whole second difference. And with that, let's copy this here. Oh, it's supposedly to be a red colored operation, so pardon for that. Let me use red for the subtraction. So you have negative 3x squared here plus 4x will be subtracted by the second product, rather, negative 3x squared minus 3x. Take note of the grouping symbol because we will be changing the signs here. You'll have negative 3x squared plus 4x. The negative sign is here. Once removed, since the grouping symbol is preceded by a negative sign, will be changed to positive. So positive 3x squared, as well as this positive 3x. And then combine, negative 3x squared plus 3x squared is 0. And you will have 4x plus 3x. The result for the second difference is 7x. Place it here, just like what happened here, but it ended already, but we haven't ended it yet here. So finally, the last step, or the last step for the second group of steps, is bring down the remaining term. And finally, the last group of steps, division. Let me write it here. Division. We have first term by first term. 7x divided by x. You may use the multiplication law of exponent or simply the cancellation law. And that is why your result for the third quotient is 7. How do I write 7 here? Do I just write it like this? Earlier, we did not place it like that for negative 3x because the sign of 3 becomes the operation subtraction. In this case, the sign of 7, which is positive, will also be the separating operation. So the positive 7 will become plus 7. Okay? That is your third quotient. Now for the third product, let me use again the red as this is supposedly the color for multiplication. Multiply the third quotient to the divisor. 7 times x plus 1. Distribute. That's 1, okay? Distribute. You have 7 times x plus 7 times 1. And you will have 7x plus 7. Place it here as your second. Uh, Let me use the orange. No, no. I use red, so I will be using red. The third, rather, third difference, 7x plus 7. And definitely, next step, subtraction, but make sure there is a grouping symbol for the subtraction process. You are to subtract 7x. Let me move it a little bit closer here. You have 7x plus 7 to be subtracted by 7x plus 7. I believe you already know what will happen since we are subtracting same expressions, but let's just continue here. 7x plus 7. By removing the grouping symbol, proceed by subtraction. Change all signs. From positive 7, minus 7x. From positive 7 here, minus 7 still. So 7x minus 7x is 0. 7 minus 7 is also 0. 0 plus 0 is 0. Here comes the final answer. Here, do not place x, as I have mentioned earlier. Let us avoid doing that here for grade 7. Let us place simply 0. So if this is 0, we are done since there are no other terms could be brought down. Whatever is at the top here, this is the result earlier. 21 is the quotient. Whatever you could see here at the top is actually your quotient. So 2x cubed minus x squared plus 4x plus 7 when divided by x plus 1 will yield 2x squared minus 3x plus 7. Mind you, it's called long division, so it involves a very long process. So this is what happened here for number 2. By the way, you could always use this long division in number 1, but as I have mentioned earlier, this is easier to be used in monomial divisor, so let's stay as it is. But if you would like to use the long division, definitely you may. So this is all about the division of polynomials. Keep on reviewing this, and again, practice will pay off as you are going to have you will be retaining more information if you are going to repeating the processes for this division operation. Goodbye, everyone.